This is Miss Neal.
And Miss Kemp.
And Miss McDaniel.
And we are going over your third 9 weeks mid-review. So let's go ahead and get started. So the first one is, what is the prime factorization of 72? So we talked about that word prime. That word prime means that we can only multiply a number by 1 times itself.
Okay. So let's go ahead and list the primes real quick. They are 2, 3, 5,
7,
11, and 13. If you can memorize these, that's probably enough to store in your brain.
There we go. Okay, so we're going to make our little factor tree. Here's 72. We got to think of 2 numbers that we can multiply by to get to 72.
If I was going to break 72, I would do 12 times 8. I mean, wait. 7 times 9.
7 times 9. There you go.
7 times 9.
Or you could do
8 times 9 would work.
8 times 9.
What did I say?
7 times 9.
No, 8 times.
It's okay. Miss Kemp can't multiply today.
So
Y'all are
I
gonna
would
multiply
do
better.
8 times 9, but if you don't know the factors and it's even, you could always divide by 2.
Oh, let's do that. Divide by 2.
Good. So we're going to do 2 times. Do we need to divide it out? Y'all want to do Nito?
Well, I know that half of 70 is 35. Y'all stop me if I'm wrong. And half of 2 is 1, and 35 plus 1 is 36.
Ooh, good mental math, Miss Kemp.
Thank you.
Okay, so then we're going to circle all the prime numbers. So far, the only prime number that I see is 2. So I'm going to circle it. Okay. 36 is not prime, though, so he gets a branch. So I can break 36 up into...
Oh, I want to do it.
Okay.
6 times 6.
Oh, Miss Kemp had redemption. 6 times 6.
Good
There
job,
we go.
Miss Kemp.
And that is not on our list, so both of these can be broken down even further into...
2 and 3.
There we go. And those numbers are both on our list as well, so those both get circles. And then if you get confused, again, we're only looking at the prime ones as circles, so sometimes I like to X out the numbers that we're not using because those aren't prime numbers. We only want the prime ones. So then I'm going to look at my bases, the numbers that we circled. So the only numbers I circled were
2
and
3.
Good. Okay.
Oh, I want to do it. 2 is going to be to the power of 3 because there's 3 2s.
Very good.
2 to the power of 3.
Okay, and then 3 is going to be the power of 2 because there's 2 3s. And then I put a multiplication sign in between them. Oh, I wrote the wrong number. Oops. There we go. 3 to the power of 2. There we go.
Can we put an X in the middle?
We can.
Yeah.
I just don't like it.
Okay. No, but I'm just saying, you can do it both ways.
Yes, you
Okay.
can have it both ways. They're
Okay.
both ways to write multiplication. Okay, so the one I am looking for is answer choice B.
Yay.
Okay, moving on. Number next.
Oh, Jim Doss.
Jim Doss. We have an order of operations.
G's for grouping.
E's for X. Oh, come on.
E's for exponents.
M's for multiplication.
D's for division.
A's for addition.
S is for subtraction.
Whichever comes first, left to right.
And I like the way Miss Kemp writes it. She also will write it, instead of writing M and D right next to each other, she'll do M over D or D over M. Doesn't matter. We always work from left to right.
Good job.
So first we're going to look at our grouping symbols. So do we have any grouping symbols here?
I see some grouping symbols.
I do too. Right here we've got these parentheses. So let's start there. So we're going to add 3 plus 6, which is
9.
Hey!
9. Very good. And I'm going to bring everything else down, keep it nice and neat.
Oh, it's getting smaller.
I see the itty bitty teeny tiny number.
Ooh, that's a
Exponent.
exponent. So I'm going to take this. Is the answer 12?
No!
No.
Wah,
Wah, wah. This doesn't mean 6 times 2. We never do base times exponent. It's always base times base. So 6 times 6. 6
all
2
about
times.
that base.
About that base. Okay. So 6 times 6 is
36.
Good. I'm going to bring everything down, keeping it real pretty.
Oh, look at you, just copying it over.
Okay, then I'm going back to my gym dots. We did, where'd it go? We did exponents. Now we're on to multiplication and division, whichever one comes first. Or division.
I see 7 times 9 first.
Good. I also see 2 times 36. So which one do we do first?
Left to right. The 7 times 9 comes first.
So now
I wonder what that is.
I don't think it's 62.
Look at that.
Can we do 63 minus 2 next?
No, we got to keep multiplying. We're not done multiplying yet. So now we got to go over to the next person in line. 2 times 36. So I've got 2 times 36, which is...
If we look at the first problem that we did, it's going to be 72.
Oh, good job, Miss McDaniel. I was not even using my brain.
So then I have 63 minus 72.
Okay.
And I'm noticing that the smaller number is first. So what does that mean?
Ooh. That means the negatives are winning.
Ooh, team negative is going to win. So this is going to end up being a negative number. Do we want to rewrite it using KCO or?
I think that's always a good strategy.
Okay, let's rewrite it. So we're going to keep, change, opposite. So keep 63.
What are we changing?
The minus sign to an addition sign. Plus
what's the opposite of 72?
Negative 72.
Yay. Oh, look at that. The negatives are winning.
There we go. And do we want to make team positive, team negative?
Yeah.
There we go. We've got 63 and negative 72. We already said negatives are going to win. I take my winner and subtract my loser. And I can't do 2 minus 3, so I got to go next door.
Knock, knock, knock.
Knock, knock, knock. Borrow. He's down to a 6. Then I have 12 minus 3,
9.
which is
9.
And then 6 minus 6 is just 0. So my answer is 9.
Negative 9.
I've got to put that negative sign. Good job, Miss Kim. Negative 9. So that's my final answer. But if we look at our answer choices, it's just looking for a part. So I need to look at all of these parts and figure out which one of these could be equivalent to what I did my work over here. So
I think I see the answer.
you see the answer, Miss McDaniel? Which one do you think it is?
I think it's C.
She thinks it's C. So let's look and see. So we need to find one that's 7 times 9 minus 2 times 36, which I see it up there in green.
Oh, I
Do y'all
see
it.
Yeah.
There it is. So that would be equivalent. So our answer is C.
We are so good.
We are.
We should get paid for this.
Oh, look, I'm in a problem.
Oh,
Yay!
yay. Let me read it.
Oh, you want to read it? Okay.
Miss Neal showed students part of the prime factorization of 84. 2 to the power of 2 times 3 times something. What number completes this prime factorization? Record your answers in the boxes. Be sure to use correct place value.
Very nice.
All right, so we're doing prime factorization of 84. So we need to put 84. And then we do our factor tree. So I need 2.
Oh, let's break it by 2, because I can do that.
Let's do 2.
All right, 2 is always good. So I'm going to put the 2 and I'm going to circle it because it's prime. All right, Miss Kim.
Okay, let me talk this out.
Okay.
80, half of 80 is 40.
Okay.
Hang on, don't write that.
All right.
Half of 4 is 2. And 40 plus 2 is 42.
Oh, I like it. All right, so I'm 2
Nice.
and I'm 42.
I'm goated.
Okay, so 42 is even and it's not 2, so I know it's going to be composite.
Well, look at you using some big words.
I know. It's like I'm a math teacher.
What?
So.
Oh, let's do 2 again.
Okay,
let's do 2
2
again.
again.
It's even.
I call this one. I call
Okay,
this
okay,
one.
all right.
So 2, and I know half of 40 is 20, and then half of 2 is 1. So 2 times 21.
All right. 21.
21.
21.
And 21's not prime, even though it always looks prime. It's not prime because we can do 3 times
7.
Oh, wow. so we
But-
said earlier 3's prime is 7 prime?
Yes, because the only
Yes.
way to get to 7 is 1 times 7.
And I remember 7-11. Those are primes. 7-11.
Okay, so I'm going to.
That's a good trick.
Oh, yeah.
I think that's how they name the store.
And I'm going to do what Mrs. Neal did. I'm going to cross off
I like that too.
those. I'm going to
Come
start
on.
doing that. 84 too?
Mhm.
Yeah,
All
I'm
right.
not using him.
So now I have 2 times 2 times 3 times 7.
Uh-huh.
So if I look up here, I have
2 to the power 2.
2 to the power of 2
Ooh, there it is.
times 3.
And we're missing 7, so
I'm
I'm
missing
guessing the blank is
7.
7.
Okay, so
Oh, be careful where you put it. Be
okay,
careful where you
where
put it.
should I put it? Should I put it right here?
No, put it right in front of the decimal.
Okay,
In the
place.
ones place. Oh, yeah,
Okay.
that's good. That's good.
And then
Yes.
on my comp test or any test that I take, I would circle or I would type in the positive sign
Mhm.
because it's a positive 7.
Or you could just leave it blank,
You could.
because positive numbers, we know, don't have a sign in front. So you could either type in the plus or just leave it blank. But negatives, you have to put in the negatives.
Can we put a 0?
Yeah,
Do we
we
have
could.
to?
We
Do
don't
we have to?
Like that? You're talking like that?
Yeah.
We don't have to.
We don't have to.
But we could
But we
if you
could.
wanted to. Yes.
Okay.
Those both mean the same thing. They are equivalent.
All right. So let's look at the next one. Okay.
Okay, Wesley wrote an equation that is equivalent, which we just said was a fancy word for equals, to 50 plus 6 divided by 8. Which expression could be the one that he wrote?
All right. So this one. What am I doing, Mrs. Kim?
Do we want to solve all these out?
Oh, that
What do
seems
y'all
like a
think?
lot. Yeah, but sometimes we got plenty of time. We
Yeah.
might as well.
Might as well.
So should we solve with that one first?
And
then-
let's look at D first, because those look really similar, and I really, really, really bad want to pick it. But I'm thinking about Jim Doss.
Ooh,
And on the first one, what am I going to do first, Miss Kemp?
you're
on
gonna
the
do
one that-
50 plus 6
Ooh,
because it's in
yes.
a grouping. It's in parentheses.
Oh, yeah, that's our VIP group.
It is.
Okay.
They get to skip ahead to the first in line. But then on D, it doesn't have it, so they don't get to skip ahead.
So what would I do first on D?
We would have
6
to
divided by 8.
Ooh, that
Divide.
seems 8.
So that
Mhm.
means those aren't going to be the same.
Get rid of D.
So
Get rid
even
of
though those have the same numbers, the grouping symbols change it
Mhm.
big time.
D. Yeah, big time.
Okay. All right.
Okay, so are we solving Wesley's equation?
Let's do it.
Okay. So I have 56 divided by 8.
Mm-hmm.
If I look at my multiplication facts, that's going to be 7. So I'm looking for A, B, and C needs to equal 7. So if I'm following Jim Doss, I need to solve the parentheses first. So if I look at A, I know 2 times 2 is
4.
4. And so then I need to do 4 times 14. So I'm going to come over here. 4 times 14. 4 times 4 is
16.
Whoop, whoop.
16. Bring the 1 all the way up. 4 times 1 is
4.
plus 1 is
5.
56.
Oh,
So
hey, that looks good. We're looking good.
we're looking
That
at
is good.
somewhere
That
at
is what we need.
56 divided by, do I do 56 divided by 2 or do I have to do something first?
No, they're in
VIP.
parentheses, so they have to go
VIP.
first.
Okay, so 2 times 4 is
8! Hey!
Eight.
That's what we need!
So 56 divided by 8 is
7!
did a fancy 7 like Mrs. Neal.
Oh,
said.
yeah, there we go. The algebra 7.
All right,
Nice.
so we're good with A?
Yeah, I think we're good. But on our test, we're going to double check, because sometimes we make silly mistakes, but we already double checked it, so we are good to go.
Okay, all right. So then, the next one. Which of the following can be written as an equation? Ooh.
Okay, so that word equation, we were talking about equations, inequalities, expressions.
Equal sign.
Yes,
Equal sign.
equation has to have an equal sign.
Okay. So what are some keywords for equal sign? I know is one.
Oh, same. Oh, equivalent. Has.
Was.
Was.
Were.
Were.
Ate.
Is.
Spent.
Is.
The
Is.
same.
Is.
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 Okay. So if I try to write these out, so A, 1/3 of a product in P. So
Okay.
1/3
Of a product and P.
Well, I know 1/3. Let's go ahead and write that fraction, 1/3.
1/3.
And then of a product, I know that product means,
Oh,
Multiply.
that's on our thing. Yeah. Oh, multiply.
and I have the variable p. So it looks like I'm multiplying 1/3 times p.
Okay, so 1/3.
1/3 p. And remember when we smush two things together, that means?
Multiply.
No?
No.
Okay, but
Yes.
the main thing we're looking for is a
Keyword.
Equal.
equal sign.
Equal sign. I don't think it's A. It's not
It's
A.
not A. There's no equal.
way. Cross out A.
No.
All of A. Cross out all of A out. Everything
So
we
I just
wrote.
get rid of the
Cross it all out.
It's all wrong.
It's all wrong. Oh,
All right.
I like B. It has an equal sign.
Okay.
It has is.
So B 2500 is, I know that's equals, less than B.
Oh.
That's
Wait a minute.
tricky though
I've
because
changed
the
my mind.
is next to less than. So now it's not an equal sign.
No, that's less than. That's less than. Get rid of B.
That's a
That's
less than
They
sign.
tricked
So
us.
less than.
They tricked us.
So don't just look for is. You got to see what comes after is as well.
Okay, C. 7 times T is.
Oh, is.
There it is. There it is.
49. So if I were writing this out, I want to do 7 times T is equals
49.
49.
Well, that looks like an equation. That looks like we should box it, rewrite it.
Ooh. Okay.
All right,
Okay.
let's do it. So let's box it.
Well, wait, you don't have to. Do you want to? Do we have to?
We don't have to. You
What?
just
I'm
act like you
tired.
wanted to.
Okay,
I don't know, right?
Okay, we're not gonna do it.
All right.
I don't know how.
Okay. All right. And then let's just try D. Just
Let's
double
do
check.
it. Let's do
Okay.
3 times 2 plus B. I don't
didn't
see
hear
any.
it. Is.
No,
There was no
is.
equal.
So no, let's
That
get rid
would be
of that.
just an expression.
Yeah.
And C is correct. Woohoo!
You know, I would like to express that we just love our students watching this video right now.
I know. I really
We
appreciate
do,
it.
we do.
If you come to your teachers and say the code word
Chocolate.
Ooh.
next week, we will give you
A chocolate.
a chocolate. You gotta come say the keyword chocolate though
Chocolate.
next week before your test.
And maybe Mrs. Basham will make an appearance for her kids to get chocolate too.
Maybe. She might know it's Friday.
Okay,
Alright.
which of the following is an algebraic equation?
Oh,
Equation.
equal sign. Equal sign. Oh, I see it. I see it. Oh my
Where
gosh.
is it, Mrs. King?
Oh, I'm
What do
so
you see?
excited.
What do you see?
I see an equal sign. Do
Where?
you? Only on letter C.
Ooh.
Only on
Alright.
letter
So that
C.
means A, B, and D are expressions,
Expressions.
not equations.
Oh, and you know what? I just want to express. I really love that the kids are watching this video.
I know, it's really
Practicing.
amazing.
It
I
is.
know.
It makes me so proud.
And writing while we're writing,
Yeah.
it's really good.
It's really good.
Next page.
Woo-hoo. Already on the next page.
All right. Which expression is equivalent to 45 divided by x plus 5?
Ooh, this looks like those properties we talked
Ooh, it
about.
does
earlier.
look like properties.
Commutative, associative, distributive, inverse, identity.
Hey,
Okay.
I don't think it's distributive because remember distributive is lifeguard.
Oh,
And
yeah.
the lifeguard is like sitting right by the pool, like touching the parentheses.
Ooh.
Ready to go?
Yeah,
Sam?
ready to go.
That
save 'em.
division
Yeah.
sign is separating. He can't see the
Yeah.
pool
Yeah.
from there.
Yeah.
So no
okay.
lifeguard.
No
No
lifeguard. Okay. So our other property, we've got commutative, which means we can
Oh.
change the order.
Yeah, like where they are. Okay.
Okay. So let's look and see if any of them are changing order.
So I should be looking for x and 5 to change, right? Because I can't change anything with the division.
Yeah.
Right.
yeah.
Division and subtraction can't change
No.
order. Only multiplication
We're
and
looking for x and
addition.
5.
So A wouldn't work because we changed the 45 and the x plus 5. We can't change that. That's got to stay in front. So he's out.
So B looks like he's out too because 45 with the division sign should be in front, right?
Yeah.
Right. Yeah, they
yeah.
totally switched places
Yeah.
there. Same thing over here. I don't know what happened. X jumped out of the parentheses.
Uh-oh.
Yeah.
So-
Okay, and then over here we have the 45 out in front. That's good.
Good.
And then all they did was switch the 5 and the x.
You can do that because it's addition.
Yeah, so
You
we
can
can do that.
5 plus x and x plus 5 same.
So that one would be the only equivalent one. So that
Awesome.
one's equal.
Yay!
Yay.
Okay. Which expression is equivalent to y times 36? So I've seen this on the warm-up before
Ooh,
in
yeah.
PowerPoint.
I have seen it too. I know that I can write this y times 36. I can also write it like this. I'm just being fancy.
Ooh, yes.
Ooh,
I like that.
All right.
So we've got our coefficient and our variable.
Nice. All right.
Beautiful.
Let's look at A. We have y times 30. Okay, I could do that. I got that. I got that. I'm gonna write up here above. I'm gonna write 30y.
There we go.
Okay, plus. I like this. I can do y times 6. It would be like if I had a yo-yo and then I did it again and again and again. I did it 6 times. I would have 6 yo-yos.
Ooh, I like that.
Okay.
Ooh, and they have the same last name. They're like terms.
Oh,
A
they
Y and a
are
Y.
terms.
So I can combine them. 30 Y's plus 6 Y's is 36 Y's.
That looks like it matches.
Ooh, they do match.
Oh, they do match. Okay, but hang on. Let's just make sure. This y times 6 is 6y.
Okay.
Okay. Plus 30.
Oh, no.
But they have different
Can
last
I
names.
combine them?
No, we can't
I
combine
don't
them.
like terms. Okay, how about this? 6y times 3.
We can multiply
Well, we
with
can.
different last names, right?
We can. So if I have 6 yo-yos and I do it 3 times, now I'm going to have 18
yo-yos.
Oh, that doesn't match.
No.
That doesn't match. Okay.
Close, but no.
All right. So, this is good. Okay, y times 30.
30y.
Y plus 6. If I have 30 yo-yos, can I add 6 ding-dongs?
No, they're not the same
No.
thing. We only have 30 yo-yos.
Do you have 16 dongs?
I would cram them in my face right
Yay.
now. Yay. Okay.
Yay.
All right. Ashley wrote the expression 6 parentheses x plus 3 parentheses plus 11 to show the amount of feed she needs for her goats, which make a lot of money, by the way. Which expression is equivalent to the one that Ashley wrote? Okay. You know how?
So this looks like the lifeguard you were talking about.
I was gonna say because I saw that 6. I'm gonna switch the color. How do I do it? Oh, okay. I saw the 6. Look at me switching the color. Oh,
Oh,
I
you know,
switched it
you
too
want to
much.
highlight. Look,
Yeah,
Okay.
where are you?
look, highlight it. There
Okay.
you go.
Okay.
Now you can write on it.
6 is the lifeguard.
Ooh, okay.
Okay.
'Cause he's outside the
He's
pool.
outside. Okay. So
And he's got to save the swimmers, which are X and 3.
so 6 jumps in and saves X by
By
multiplication.
multiplying.
Power of multiplication. That's 6X.
Good.
Then the lifeguard gets the floaty. What's the floaty, y'all?
The addition sign.
Good. And then 6 jumps in and saves 3.
By multiplying.
6 times 3.
18.
Okay. All right. Does that help us? Okay. Now what do we do? Which expression is equivalent? Ooh. That means
Equal. And we still have this plus 11 too. Don't forget that.
Oh my gosh.
Does the
that's
lifeguard
totally-
need to
He's
save him
still
though?
hanging out. No, because he's not in the pool. He's just chilling
No.
outside the pool.
That's that mom on her phone.
Oh,
You know.
she needs
with
to
the-
get off her
She totally needs to get off her phone.
But I do notice that we have some like terms here, right? We've got a regular 18
Oh, yeah.
and a regular 11.
I like that. I call these naked numbers.
I
We
call
can
them no last name, or no last namers.
Can we put those naked numbers together?
Yes, we can.
Yes.
That's what we've been doing since elementary school, just
Okay.
adding regular numbers.
So 6x plus
29.
18 and 11, 29. All right. We're looking
And
fine.
Can I combine those, Miss Kat?
No,
No.
they don't have the same last
Oh,
name. They're not
okay.
like terms. No, we
Okay,
would not match
so that's
them.
my final answer.
Yeah, then
Okay.
we simplify. Okay. So let's look at A. What would we do first?
Multiply the
Multiply.
6 times the x.
That looks like 6 times times
I know.
6. Okay, so 6 times x.
The 6x.
6x.
What they were saying, 6s.
Okay. And then
times 6 again.
times 6 again, and times 3. Oh my gosh. And then times 11.
Nice.
Oh, this is going to get big fast.
Okay, so 6 times 6 is,
36. I'm going to have to go like this.
there you go,
Making a big all hot mess. 36 x.
x. Good.
Okay, and then I didn't use the 3, and I didn't use the 11, so I'm going to say times 3 times 11.
I think my x's are going to be way bigger on this one than.
I know they're already
Yeah.
way bigger. We got 36 x's. We only
6
need
X's.
Yeah.
6 x's.
Yeah, we only needed 6. Look at me not writing this. Okay. All right.
Okay, so A's out.
A's out.
Wah, wah, wah.
Bye. See you never.
Okay, sorry. Okay, so this
Okay.
is good. We got this. Okay, 6 times x.
Good.
Okay, so that's 6.
And notice we're multiplying first. We're not adding or
X.
anything first.
No,
We gotta multiply
No,
first.
gotta do the multiplication. Okay, plus
Again, we need to multiply
We
first.
need to multiply.
6 times 3 is?
18 plus 11.
Hey, Miss Kim, it looks exactly like the one we had on top.
Watch me get my highlight. Okay,
Ooh,
like
there we go. Yep.
Right here matches this right here.
Oh my goodness. So that means they are equivalent. They're equal.
Okay, let's just make sure. Okay, this is 6 times x. That's 6x.
Good.
Okay, times 6 again.
Uh-oh.
Oh my God.
That's going to be that 36
Yeah,
again.
no.
That's way too big.
No bueno. Okay, 6 times x, we got a 6x. Plus 6 times 3, we got an 18. Plus 6 times 11, 66. See how I did all the multiplication? I did all the multiplication.
I like that.
Good.
I did that. Now I have some like terms I could combine, but this is not matching at all, so I'm going to mark it out.
Yeah, 66 way too big.
So we're
Way
good
too
with B.
So we're going with B.
B.
The lowest for Ashley's go.
And the keyword is? The code word is
Chocolate.
If you watch the video and talk with your teacher.
Okay, number next. What is the value of the x coordinate? That's kind of important. I'm going to highlight that. X coordinate for E. Record your answer in the boxes. Be sure to use correct place value.
Be sure to use correct place
Don't know what I said.
All right, so
Dramatic
we're
effect.
looking for the x coordinate. So remember we have the x-axis and the y-axis. It's labeled for us, but we're going to go ahead and label it again. And then remember when we write them, we're going to write the parentheses. And remember, x always comes before y. When we graph, x comes before y. When we write it, x comes before y. When we say the alphabet, x comes before y. X always comes before y. So they're talking about point E, so do I really even care about these other points?
No!
No way.
Bye-bye.
So
Bye.
starting at the origin, remember x before y, or we walk before we climb up or down the stairs, or however you want to remember it. But so starting from the origin, I'm literally going over. Oh, there's E. Sorry. Oh, look, it made a cool line.
Oh.
Okay,
It's
that's what I
elevator
meant.
5. We're getting an elevator 5.
So I went over 5. So I know that my x coordinate is 5.
5.
And I can really stop there, but I know a lot of y'all are going to find it anyways. My y coordinate would be 5 as well.
Negative 5.
Oh, you're going
Oh.
down.
Because we're going down to the
Going
basement.
down.
Down to the
Good.
basement.
Good.
I don't want to go.
Don't do it.
So
should
negative
go.
5.
Okay.
So I'll have kids trying to put 5 comma negative 5 into here.
You
Can I put that in
commas
there?
in there?
You can put commas in there.
No, or
Miss-
parentheses.
Miss Neal, how do I put a parentheses in here?
You can't.
Oh, so that doesn't make any sense. So go back and reread the question. I'm looking for just the x coordinate. So this is really the only important piece of information. Okay, all those points are extra. The y is extra. Don't need it. Okay, so I need to make sure that I put the positive 5. And remember, that is a 5 whole, not a
Be
decimal.
sure to use correct place value.
Correct place value. Now, is it okay if I put these zeros here?
Yeah, it's okay.
Yeah,
You don't
yeah.
have to.
You don't
Let
have
it
to.
fly.
You can if you want.
Yeah, if you
Okay,
want.
they're useless. You don't need to. If you want to put them there, it's not going to hurt anything. And then, does it need to be negative?
No, it's
No,
positive.
Positive. Do I have to put the positive sign?
No.
You don't have to. Remember, if you leave it blank, you don't. It'll make it positive automatically, but it is positive 5.
Yay!
Hey,
Basham.
thanks, Miss Basham.
You're awesome.
There are 4 points graphed on the coordinate grid. Which ordered pair is not represented by the points?
Okay, so I think I'm just gonna. Do y'all want to do all the points, or do you want to start with the answer choices and knock them out? How would y'all work this?
I'm trying to be more like my quality test takers and start with the answer
Ooh,
choices.
I like
Because a lot of
that.
times I forget. Yeah, start with the answer
Okay,
choices.
so let's start with this one. So A is -8, 4, and like Miss Basham said, it's always x, then y. Okay, so I'm gonna go to my graph, and again, I'm gonna label it. This is my x-axis. This is my y-axis. So I'm going over -8, and I always start where?
The origin.
The origin.
The zero.
0, 0. This is always my starting
Home.
spot,
Home base.
home base. And I'm going all the way over to -8. So that's to the left, or the negative numbers. I'm going over here to -8.
Okay.
And then I'm going positive 4, which is
Up to floor 4.
up to floor 4.
Get in.
So then when I graph it, it has a little point there. So he is actually on the grid. Is that what we wanted?
Yep.
Oh, no.
Which one is not?
Not.
So I think we should put a check by A just to say, okay, A is on
So
there.
it works, but that's not what we want.
Oh.
Okay, number
This
next.
next one. Ooh.
Ooh. -7/2. So
Oh, that means divide.
that means divide. That's like saying it like this.
Yeah.
-7 over 2.
Uh-huh.
So some of my kids like to turn it into a decimal. That helps them.
Yeah.
What do y'all
Yeah,
think?
I like
you
to
can-
do that
Yeah,
too.
you can
Okay.
neato.
So if we wanted to neato that,
Yeah.
this is my Ned.
Uh-huh.
This is my donkey. So I've got 7 in the house
Uh-huh.
and 2 outside. And I know 2 goes into 7.
Oh, three times.
times.
3 times.
3. 2 times 3 is 6. 7 minus 6 is
1.
1. Okay, then what do I do?
You added decimal 0.
Okay, drop it down. And 2 goes into 10.
5 times.
5 times. Good. And then the one thing we can't forget about is my
Negative sign.
negative. So this is really over -3.5 or -3 and 5/10, and then 0. Okay, so let's go over -3.5. Is that left or right?
That's going to be left because it's negative.
Okay, and then I'm going over in between. Am I going to be in between -2 and -3 or -3 and -4?
-3 and -4.
Okay, because if I were between here, I wouldn't even be to 3 yet.
No.
So that wouldn't be enough.
That'd
So I'm going to be over here.
-2.5.
Okay, and then I'm going up 0. So I'm not moving any. I'm staying right there.
Yeah, and it's supposed to be on the line, but
Okay, so that guy's supposed to be on the
Technology, you
line. Yeah. Oh, so that one is actually on our line. So that one is
nice.
good, but we
Not
want the one that's not. Okay, let's look at number next. We're going over 3,
Up 2.
up 2. So here we go. Over 3, up to 2. Oh, look, and there's a dot there.
Oh. We want the one with
So that one's
not
good, which is
represented.
not it. And then this one again, this is saying division, -6 over 2, which that one we really don't need to do neato for. I know
No.
6 divided by
Yeah.
2 is
-3.
-3.
Good job on the
Yeah,
negative.
yeah,
Miss.
they
Yes.
don't like each other. Dorito man.
Yeah.
Got it.
Yeah.
So 3 over -3, which is going to be to the left. 1, 2, 3.
Mm-hmm.
And then I guess I should change colors.
You're so fancy.
Sorry.
Fancy
Okay,
life.
over -3, up all the way to 7. And if y'all look, there's not even a dot up there. There's nothing going on.
Nothing.
So that's our one that's not on the board. So our answer is
D. Like dog.
Okay, number next, if we're writing, looking for our keywords.
After Brady put 7 new fish in his aquarium, he now has 21 fish. Which equation can be used to find F, the total number of fish Brady had before the 7 fish were added?
Okay, so I circled my numbers. Now I said let's go through and look for our keywords.
Oh, I saw one.
Ooh, wait, which one did you see?
I saw has
Ooh.
21. I think that's equal. I'm looking at my little half paper here.
right, because we know
Has.
is equal
Yeah.
and has is past tense of is.
Has, was.
Okay, so that means equal. And then I saw added.
Oh,
here.
yeah. Yeah.
Added.
Oh, that means plus.
That means plus.
Mhm.
Okay, so do you think we have everything we need?
We're going to have that variable F.
Okay, variable F.
Yeah. Okay, I think we do.
Okay, so I know it's going to equal 21.
Yeah.
So this is going to go over here on the right.
And,
And I know I'm adding.
yeah. And he's put 7 in. So
Okay.
he's adding 7.
So we're adding 7. Do we know how much he started with, though, before he added the 7?
I don't know.
No, so that's our variable. That's our unknown. We don't know what that is. So we're
You
going to use
have an
F.
I don't know. You put a letter.
There we go.
I don't know.
So F plus 7 equals 21. Ooh, I see it.
I see it.
B.
Nice.
Yay.
Oh, it can't be C because that's times
Oh, yeah, that's times.
There's
And these division.
Yeah.
That doesn't make any sense.
And he didn't take any fish out, so
No.
it's not minus. Okay,
There we go.
we're golden.
Okay, which situation can be represented by the equation 18 and 5/10 equals 9 and 2500ths, and that little s we're timesing, 9 and 2500ths times s. So let's look at A. I'm going to mark it up as we go. Bailey bought necklaces for a total of $18.50. So
I like that it starts with that.
$18.50. And I also saw the keyword
Total,
which means
equal.
And then it says each necklace is $9.25. What is S? There's our variable. The number of necklaces that she bought. And I also saw a keyword each.
Yes.
Yeah, each.
Each means multiply.
Yes, and it's also on for division, but it kind of depends on the word problem.
Yeah, it's one of those
So,
that goes both ways.
We're not going to be dividing out the necklaces, right? Though.
No.
No. So this one's going to mean multiply. So we want to write the equation for this one?
Let's do it.
I know it's going to equal $18.50.
I know we're multiplying, and we want to put the number touching the letter.
Yes, and
my other number is 9.25, $9.25. And did they give us a letter?
S.
Oh, they did, the S. Oh.
S. Hey, look, that looks like what we need.
Oh.
It's just reversed. Is that okay?
Oh, it is. Oh, yeah. They started with the 9.25S, and then it equals. Oh, they just flipped it.
Well, looks like that could be the answer. Do we want to write the other ones, or are we good?
I think we're good.
Okay. And on your test, though, you're going to mark them all up and write all your equations.
Yeah.
Ooh, area.
Dun, dun, dun.
The area of a rectangle, we know what a rectangle looks like, is 62.5 or 62 and 5/10. And I also saw the word what, Miss Kemp?
Area. What?
Okay.
Yes.
An area. An area, sure.
I was looking at the answer choices like good students do.
Oh, good. It is 62 and 5/10 square inches. The base of the rectangle is 5 inches. We want to know what the height is. So I always tell my students to draw me a pretty picture of what's happening. Too. So we have a rectangle.
Mm-hmm. Oh, the base is 5.
The base is 5 inches.
That's the bottom. Base is bottom.
Probably should have drawn that different. Oh well. This is not the scale. Okay. 5 inches. And then I know area, is that the rim around or is that the inside?
That's the inside, like the carpet on the floor.
So all of this.
Yeah, all that.
So I know that the area equals 62.5 inches squared. Do you know that formula for area, Miss Kemp?
I do, because
you have your formula chart in front of you.
I have
and
my
you're
formula
looking at
chart right here. It says base times height. But I also know we can do length times width.
Ooh,
so
okay.
Whichever one makes sense to you.
I'm going to do length times width.
Yeah, I know they did that last year in 5th grade.
Should I do base and height since it's in the word problem?
Maybe.
I don't know.
We can go either way.
We'll write both of them.
Yeah. We're just talented like that.
Base times height. So now I'm going to plug in the stuff I know because it gave me stuff.
Yeah.
So it told us that the base is
5.
So everywhere I see a B, I'm going to plug in
a 5.
Okay. And then it also told me the area.
Oh, so A for area.
Is 62.5.
Yeah.
So everywhere I see an A, I'm going to plug in 62.5.
Oh, we're going to actually have to solve this.
Ooh, fun.
Okay.
Okay, and then I'm looking for the height. So that's going to be my unknown. That's my variable.
I don't know.
I'm just going to leave it height, or an H for height.
If you have an I don't know, it's a variable.
Okay, now we're going to do our strategy. We got to get H, figure out what it is. So we are going to
box it,
rail it,
and rewrite it.
There we go. Okay, now we're trying to get H by himself. Why is H not by himself right now, Miss Kemp?
That 5's touching.
Ooh, we need to get rid of him. So right now when they're touching, we know that's multiplying. So I need to do the inverse or the opposite
of multiplication is
Division.
I
So
love
I'm
how
gonna
you
divide
show
by
it with a
5.
fraction mark. That's really good division. Show it with a fraction mark.
Yeah.
I like that.
Okay. Then we're going to, whatever we do on one side of the equation,
We have to do to the other.
there we go. Okay, this side's easy. I know when I have a 5 divided by a 5, I get
1.
1. So this is 1. What's his last name?
H.
H. And I can write it as 1H, but
No,
really
that's
us
weird.
mathematicians don't
Yeah,
do that. We
that's
just
weird.
say
H.
H because there's 1 H there. Okay, then I've got to divide 62 and 5/10 by 5.
Oh, let's do a division.
I'm going to have to do Nito because I don't know that off the top of my head. So here's my Ned. Here's my donkey.
This is a vinculum. That symbol, that house, it's called a vinculum.
Oh, I learned something new today, y'all.
Yeah, vinculum.
I like it.
Okay.
Okay, so 5.
Oh, pop your decimal up.
Oh, yes, thank you.
Because
We're going to raise the roof.
Raise the roof.
Raise
Let's
the
do
roof.
it.
Okay. So 5 can go into 6.
One time.
One time. And 1 times 5 is
5.
5. 6 minus 5 is
1.
then
Bring
I'm gonna
down.
Bring down. 5 can go into 12.
2 times, because 2 times 5 is 10.
There we go. Subtract.
2.
Ooh, very good.
Bring down.
We have Mr. Foster here.
I know.
Okay. 5 can go into 25.
5 times. 5 times.
Ooh, and that goes in there perfectly.
Yes. Score.
So we get 12 and 5
tenths.
Inches.
12 and 5/10 inches. Look
Yes.
at the answer choices. I see it. See.
Whoop whoop.
See you on the next problem. All right.
Okay, Beverly typed 72 words per 1 minute. She wants to type more than 360 words. Which inequality represents all possible values for m? The number of minutes Beverly needs to type. Oh, to type 360 words.
Be sure to use correct place value. Oh, wait, that's not this one. Okay, so I've highlighted that word more than because I know that more than
means greater than.
Greater than. So wait, which way does it
Ooh.
face?
So I know that the word she's got to type has to fit. Oh, I know if I hold up my right hand, it's greater than and make an L, and my left hand makes a less than.
Look how I made the line straight for me.
Yeah, if you hold it down, it'll make it straight. It makes like your shapes pretty.
Okay, greater than. I also know that it's pointing to the big numbers, so that's the greater than.
So, hey, can we go through the answer choices real quick?
Yeah.
And cross off any?
That is so good
Ooh,
because that's
yes.
what good students do. Okay, yes.
Okay, so I know A is good. It looks just like the one Miss Kent drew.
Yeah, those are same.
Ooh, B is less than.
Oh, look at that. Look at that. Okay.
Get rid of them.
Okay.
Ooh, C is less than. Hey, just by knowing the word more than, we've got a 50-50 shot if we had to guess.
Nice. That's nice.
But
And
we're not
plus-
going to guess.
Plus, we watched this video, so we're going to get chocolate and a 100.
Oh,
That's
there
so
we go.
cool.
That is
Okay.
awesome.
All right.
Okay.
So Beverly types
72 words per
minute. So I know I need this 72, right?
Yes.
Okay, and then I see this word per. Did you have your students add this? We added this to our list. We added per.
I have it for multiplication.
Yes, we have it for multiplication. Okay, so we're going to write this inequality, right? Okay, so I know I need this more than symbol. Oh my gosh, this is so fancy. I can't, Neil.
You can hit the back button.
Okay,
Reverse your. Oop.
okay.
There you go.
Help me out. I can't do it.
There you go.
Okay. I
Okay.
know I need greater than. Okay. She wants to type more than 360 words. So I know more than that. Okay, so I'm going to put more than 360. Okay. So I've got a 72 and I need a letter.
Ooh, well, they gave us the letter M.
I think they're using M.
Yeah.
Okay. So we're going to do 72.
And then that word per, we said was
multiply. Oh, this was multiply.
So 72 times M.
Oh, they just have to touch.
Yeah, just smush them
Just
together.
smush them
There
together.
we go.
Okay.
Ooh, now we get to solve another one.
Okay, so I box it.
Rail it.
Rewrite it. Greater than 360. When I rewrite it, I read it. 72 times m. Times is multiply. What's the opposite of multiply?
Divide.
Divide by 72.
72.
Divide by 72. 72 divided by 72 is 1. Blow it up. M is greater than, ooh, I don't know that.
I don't know that
So
either. I'm going to have to
go-
Ned and Donkey it.
How do I go? I can't go over there?
You can go over there.
Okay, I'm going over there. I'm going over. All right, I'm drawing a vinculum.
Oh, yes. It's my new word of the day.
360 divided by 72. Ned went in the house. The denominator, donkey, 72, was outside the house. Will 72 fit into 3?
Definitely not.
Don't put anything on top of the 3. Will 72 fit into 36?
Definitely not.
Don't put anything on top of the 6. Will 72 fit into 360?
Yes.
I'm going to guess.
Hey, let's look at our answer choices.
Oh,
That'll help
dude!
us.
That's so awesome. Oh, 0.5 or 5? Well, duh, it's not 0.5.
It's not 0.5.
It's gotta be
It's gotta
5.
be 5.
Oh, yeah, I'm check it out right here, like 5. Okay.
2 times
Yeah.
5 is 10. Carry the 1.
Oh my gosh.
360.
360. Okay, so we got it. Our
Woo!
answer is 5. Oh,
Not
our
it.
answer is 5.
5.
M has to be greater
Greater
than
than
5.
5. Answer choice D.
D.
Woo-hoo.
You're much faster at writing than me. Yes, you are. I promise.
Okay.
Okay.
The area, oh, we just did one like this. The area of the rectangle is 132 square feet. What is the length, L, of this rectangle? Oh, they already gave me a pretty picture.
Nice.
So I know we already talked about the area is the inside, like the carpet, Miss Kemp said. And they already told me the area was 132 feet squared.
Okay, I'm looking at my reference chart, but I remember it too. The formula is area equals base times height. And they just put the B and the
There you
H
go.
touching, because that means multiply if they're touching.
Okay, so now I'm going to plug in the things that I know. So I know area is 132. So
yeah.
everywhere I see an A, I'm going to put in
132.
132. Okay. Then I've got my base,
We don't know it.
which we don't know. That's my length. That's this part.
Yeah,
we don't
the
know.
bottom.
They just put an L there. So I'm going to leave that as base. And then we've got our height,
Oh,
which
we know it.
they told us in the picture. What's our height?
6.
6. So everywhere I see H, I'm going to plug in
6.
6. Okay, and this is kind of bugging me. Can I rewrite it, Miss Kemp?
I would rewrite it.
I
Yeah.
like to have the...
Yeah, 32 equals 6b, because we
There
put
we
the
go.
coefficient, then the
There we
variable.
go. Yeah.
Oh.
Okay, now we get to solve.
Oh, I know. Box it,
Box it. Ooh, box it.
rail it,
Reel it.
rewrite it.
Okay, so I'm trying to get the variable b by itself. So right now it's being multiplied. I got to do the opposite of multiplying.
Divide.
Divide. I'm dividing by what?
6.
6. Whatever I do on one side.
I have to do to the other.
Okay, over here I've got 6 divided by 6 is
1.
1. He's gone. I can blow him up.
Yeah.
Blow him up.
Yeah, I like
So 1b, or just
B.
b. And then I've got 132 divided by 6. I'm
Oh,
not,
draw a vinculum.
not sure. Oh, yeah, I got to get my vinculum. Okay, Ned,
Donkey.
donkey. Vinculum drawn. 132.
Numerator in.
Denominator
Uh-huh.
out. Okay.
Okay.
Can 6 go into 1?
No, don't put anything on top.
Okay, can 6 go into 13?
Yes, 2 times.
Ooh, 6 times 2 is?
12.
13 minus 12 is?
1.
1. I bring down my 2. Hey, we just did this.
Oh, I did.
6 goes into 12?
2 times.
2 times. 12 minus 12 is? 0.
0.
We're done.
22.
22.
What letter is 22? B equals 22. 22
Ooh.
equals B.
Hey! Yay!
That's what those Canadians say. Hey.
Hey.
Okay. Mike filled up his gas tank before he went out of town. With his full tank, he could travel 325 miles. After his first day, he used up 40% of his tank. How many miles did he travel? Oh, this is my favorite. Can I say it?
Yes,
Okay.
please.
I saw the percent and then the number, and so I was thinking line equals line or fraction bar equals fraction bar.
Yes.
And I was kind of looking around the room and I saw that anchor chart, And I was like, yeah.
Yeah.
Fraction bar equals fraction bar. Oh, put the 100 in that bottom corner.
Yes.
Yes, right there.
And then
Okay.
percent always goes
Goes
on
on
top,
top.
which
Yeah.
we have that.
We
What's
have
the
that.
percent?
It was with the percent sign. It's a 40.
40. That one's easy to spot. It's got the percent.
So.
Okay, now the hard part is figuring out what's my part
Mhm.
and what's my whole.
Okay.
So we've got number 325. So with this full tank, he could travel 325 miles. So I'm thinking with a full tank, that means the whole
thing.
tank.
Yeah, I think so too.
So I think I'm going to put this for whole.
I agree.
Sorry, Missy likes to color code everything.
I like it.
Okay.
I wish I was as fast as you.
So then the part is my unknown. That's what I don't know.
Mhm.
Do we want to put a variable there or just leave it? What do you want to do?
Well, let's just leave it because maybe we put our answer once we know.
Oh, okay. Sounds good. Okay. So we can either do it the old way where we figure out, okay, 325 times what gives me 100, or we can do it our new fancy way, which I think might be the better way with these
I think
numbers.
so too. Let's cross multiply.
So we cross multiply our two numbers. We've got 325 times 40, which I don't know. So let's go. We're going to do it.
Yeah, I don't know either.
325 times 40. Ooh.
Oh.
0 times everything's just
0.
0. He's done. Okay, and then I have to remember to do what, Miss Kemp?
Put a placeholder 0.
Bam. Okay,
Yeah.
and then I've got 4 times 5 is
20.
20.
Put the 2 on top.
Okay, 4 times 2 is
8.
plus 2 is
10.
3 times. Oh, sorry. 4 times 3 is
12.
plus 1 is
13.
Miss Kemp's got a fax. Then we have to add everything up. 0 plus 0 is
0.
0 plus 0 is
0.
0 plus 0 is
0.
And I just bring down my 3 and my 1. I don't have any kids in my car. There's no decimals. So this is going to be 13,000.
Oh, that's not an answer. Oh, because
No.
I know why.
Why?
Because see that we had that 100.
Oh, we didn't
have
use
to
them.
divide by 100.
Ooh, we
You
divide
divide by
100
whatever's
piece.
left over.
So I've got 13,000. 13,000 divided by, is it okay if I use the fraction bar?
Yeah.
Okay.
Oh,
Divided
you know what
by
we could do?
100.
We could do that 0 trick.
Ooh, when there's a 0 on top and a 0 on bottom.
You can cross them out.
Bye-bye. Bye-bye. So now it's really just 130
30.
over 1, which is really just
130.
130.
Is that a choice?
That's a choice.
Woo!
D. Woo! Look how easy that was. Miss Kemp.
Detail.
Ooh, a number line.
Ooh, our favorite.
Ooh.
Oh, and it's the 0 to the 0.5 number line. Whoop, whoop, our favorite.
Ooh, yeah. And they're not labeled. So what's the first thing we're going to do, Miss Kemp?
We're going to label
We're
this
gonna
number.
label it. Yeah. So let's just look at it. So we always think in money, right? We always think about
Think of
going
money.
from 0, and I'm going to add an extra 0 so we can think about
Yeah, money.
50 cents.
50 cents.
Okay, then do we want to try to figure out maybe our halfway?
Yeah.
There's ticks here too, y'all.
There are.
Okay, so it looks like our halfway is going to be about here.
Yeah. Oh, I know half of 50 cents.
What's half of 50 cents?
25.
Ooh, there we
Because it's a
go.
quarter.
Ooh, it is a quarter.
Yeah.
There we go. 2 quarters to make.
You know, I used
50
to
cents.
could buy a Coke in the Coke machine for 50 cents.
Nuh-uh. I
2
don't
quarters.
believe you.
Yeah. And I used to use the payphone, and I would put a quarter in. long time ago.
Oh my
Okay.
goodness. Okay, so 25 cents. How do you break it up now, Miss Kemp? Do you want to just look at 0 to 25 cents?
Yeah, I might try I tried other money things like count by 5 cents, count by 10 cents.
Okay, so
Let's try 5 cents.
5 cents?
You think? Okay.
Okay, so this would be
0.05,
Five.
a nickel,
this would be
10 cents. Oh, it's gonna work.
15,
And
20.
20 cents.
Ooh,
and
then 25.
So
So we got
30,
30,
35 cents, 40,
45,
and
50. Oh, it works. Yay.
What are they looking for?
So we want to know what 1/5 is.
Oh, this is a benchmark.
This is a benchmark. We should know this.
We should totally know this. Oh, okay, that's
But our fancy little trick, if we have a 5 on bottom, we can just multiply the top
it's
by
double the tenths.
2. So this is really
0.2. 20 cents.
20 cents, which
Yeah.
is
Q.
Q. Answer choice
Q.
B. And if I didn't know my benchmarks because I didn't want to have less work, I could do net and donkey, but I highly
Neato.
suggest you know your benchmarks. You don't have to neato.
Mm-hmm. Or if you had a calculator, I guess you could just.
That's true. Okay, number next.
We're almost done.
there?
Yeah, 2 more.
Okay,
Last
the table
2.
shows the relationship between J and K. Ooh, ID. Don't forget your ID or you will die. IX, DY. Okay, so where J is, it even tells us, look how nice they are. Where J is the independent variable.
That's very nice.
I know.
We already did it though.
Which equation represents the relationship between J and K?
Oh, I know. My teacher tells me that we always start an equation with the dependent.
Oh, that's
variable.
A good trick. So in this case, our dependent variable is
K.
K. So any of them that don't start with K are out.
Out. B.
Oh, look, 50-50 shot just by knowing my dependent variable. Oh, my goodness.
Dependent starts the equation.
There we go.
Depends on what happens.
Okay, so then I've got to figure out what's happening. How am I getting from my independent to my dependent? Let's look at our answer choices to help us out.
Times 1/3. A is 1/3 J. That means times. Or C is J minus 1/3. Oh. I don't think they're subtracting.
No, because if we do 1 minus 1/3, we're not going to get 1/3.
No, we're going to get 2/3.
So I don't think this one's going to work. But I do know 1 times 1/3 is just going to be 1/3.
Oh, that worked.
That does work.
Happy
does it work
face.
for this one?
Yes.
Yes.
2/3.
If I have 2 times 1/3,
multiply
tops by tops, bottoms by bottoms. 2 times 1 is?
2.
1 times 3 is?
3.
Ooh, yay, that's what we want. So it looks like A is our answer. Whoop, whoop. Use your answer choices.
Last one.
Soak it all in, guys.
Okay. Comedy hour's about to end.
Aw, so sad. You can rewind it, though, and watch it again.
With your family.
Yeah.
And your friends.
Yes.
And if you call now, we'll include this last answer for free. All right. Maybank High School basketball team drinks 60 cups of Gatorade every 9 games. How many cups would the team need for the whole season, which has 27 games?
Ooh, so this looks like we're going to be making a portion, a UKSN problem.
I saw those 3 numbers, UKSN.
Woo.
We got it.
Okay, so what are our units, Miss Kemp? What are the 2 things we're talking about?
Boogers and tacos.
Definitely not.
Okay, it's never that. It's
never
that.
boogers and tacos.
Okay, they're talking
Maybe
about
one
cups.
day. Okay, cups.
And games.
And games. Okay.
You know who's got game? Miss Basham's got game.
Ooh, Miss Basham does have game.
Yeah. Okay. Cups.
Okay, so
maybe
what do we know?
We got
I didn't
units
label.
First.
I'm sorry. I'm getting ahead of myself. I'm so excited.
It's the last one. Game.
Just love you, Kate. Okay, cups and games. So I know that the team can drink
60
cups.
That's a canoe.
Okay, I know that.
Canoe.
Okay, so 60. And how many games does it take them to do that?
How many games would the team need for the whole
It takes them
season?
9 games to do that.
Okay. Yeah, I was looking at the question.
Oh, okay.
The question helps me know what we're looking for.
Oh, yes.
What we need.
Okay. So the question's asking us what, Miss Kemp?
How many cups?
Okay, so am I going to be putting anything up here for need?
No, I don't
No,
think so.
because that's what I'm looking for, right?
Mm-hmm.
But then I have games.
Oh, 27.
27.
Those on the games row. The games row.
Oh, they're not my scale. Down here. That's what I need to get to.
Yes. Nice.
Okay, so now we're trying to figure out our scale. So I can't figure out the top because there's not a number to get to.
I know it. I'm looking at my multiples chart in the back
We
of
can
the
look
room.
at the bottom. 9 times what gives me 27?
3.
Ooh, 3. And whatever I do to the bottom?
I have to do to the top. It's the scale.
Okay, so 60 times 3. Let's do a little math trick. Let's get rid of that 0 real quick.
Okay.
What's 6 times 3, Miss
18.
18. Okay, now let's add the 0 back on.
Oh, look at that. That's
Bam!
magic.
180.
Is that a choice?
It is twice. 180 cups in 27 games. You did it. You did your math review. If you watch this whole thing, you're going to make a really good grade on your test.
And we're super proud of you.
Yes. Happy studying.